This is SpaceTime, Series 24, Episode 69. Coming up on SpaceTime, no plate tectonics on Venus, the first X-rays from Uranus, and searching for signatures of life on other worlds. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new study claims Venus hasn't had any plate tectonics on its surface for at least 300 million years and probably more than 1 billion years. The findings, reported in the journal Nature Astronomy, are based on a study of Meade Crater, Venus's largest impact basin. The 170-kilometre wide crater was formed by an asteroid impact between 300 million and 1 billion years ago. Meade is surrounded by two cliff-like fault ring mountain ranges, rocky ripples created by the basin-forming impact event. The authors claim their models suggest that for those rings to be where they are in relation to the central crater, Venus's lithosphere, that is its rocky outer crust, must have been far thicker than that of the Earth, which means Earth-like tectonic plates couldn't have been present at the time of the Meade impact. Earth's plate tectonics are characterized by mid-ocean ridges of sinuous mountain ranges, where molten material from deep inside the planet flows out onto the surface. There it cools and hardens into rafts of rock drifting on top of a slowly convecting mantle until it reaches the lighter continental crust, where it subducts back down into the mantle. Previous observations from orbital spacecraft have revealed rifts and ridges on Venus that do look similar to plate tectonic features on Earth. But Venus is shrouded by its thick atmosphere, making it hard to make definitive interpretations of fine surface features. So this new study is a different way of approaching the same question, using the Meade impact to probe the characteristics of Venus's lithosphere. It follows earlier research studying the similar Orientale basin on the Moon, which showed that the final position of the rings is strongly tied to the crust's thermal gradient, that is, the rate at which rock temperature increases with depth. See, the thermal gradient influences the way in which rocks deform and break apart following an impact, and that in turn helps determine where the basin rings end up. The work shows that for Meade's rings to be where they are, Venus's crust must have had a relatively low thermal gradient. And that low thermal gradient means a comparatively gradual increase in temperature with depth, and all that suggests a fairly thick Venusian lithosphere. The study's lead author, Evan Bjones from Brown University, says the findings show that Venus had a stagnant lid at the time of the impact. And he says that's a bit like a lake freezing over in winter. The water at the surface reaches freezing point first, while the water at depth is a little bit warmer. Then, as the deeper water gradually cools down to similar temperatures as the surface, the ice gradually thickens. The calculations suggest that the thermal gradient is far lower, and so the lithosphere much thicker than what you'd expect for an active lid planet. And several other ring craters examined by the authors were also proportionally similar to Meade, showing similar thermal gradient estimates. The findings all support the idea that planet Earth is rather unique in our solar system because it has a system of global tectonic plates. And that's affected how the Earth has evolved and how life has developed on the planet. This is SpaceTime. Still to come, astronomers have detected X-rays from Uranus for the first time, and the search for signatures of life on other worlds. All that and more still to come on SpaceTime. Astronomers have detected X-rays from the planet Uranus for the first time. The findings, reported in the Journal of Geophysical Research, will help scientists better understand this enigmatic ice giant. Uranus is the 7th planet from the Sun and has 2 sets of rings around its equator. The planet has 4 times the diameter of the Earth, similar to that of its fellow ice giant Neptune. But it rotates on its side, making it very different from all the other planets in our solar system. Since NASA's Voyager 2 is the only spacecraft to ever fly by Uranus, astronomers have relied on telescopes to learn what they can about this distant cold world, made up almost entirely of hydrogen and helium. A new study analysing earlier observations of Uranus taken by NASA's Chandra X-ray Observatory in 2002 and 2017 detected X-rays from the 2002 observations as well as a possible flare of X-rays from the 2017 readings. Astronomers think the X-ray emissions are actually being caused by the Sun. They've observed that both Jupiter and Saturn scatter X-ray light given off by the Sun in a similar way to how Earth's atmosphere scatters sunlight. While the authors of the new Uranus study initially expected that most of the X-rays would also be from scattering, there are tantalizing hints of at least one other source of X-rays, which, if confirmed by future observations, could have intriguing implications for understanding this distant world. One possibility is that the rings of Uranus are producing the X-rays, similar to what happens with Saturn's rings. See, Uranus is surrounded by charged particles such as electrons and protons in its nearby space environment. If these energetic particles collide with particles in the rings, they could cause the rings to glow in X-rays. Another possibility is that at least some of the X-rays are coming from Aurora on Uranus, a phenomenon that had previously been observed on this planet at other wavelengths. On Earth, colourful light shows in the sky known as aurorae happen when high-energy charged particles in the solar wind interact with the planet's atmosphere. X-rays are emitted by Earth's auroral activity, produced by energetic electrons after they travel down the planet's magnetic field lines towards its poles and are slowed down by the atmosphere. Jupiter also has auroras generated by the solar wind as well as by charged particles thrown into space by volcanic activity on the Jovian moon Io. However, scientists remain less certain about what causes auroras on Uranus. Chandra's observations may eventually help to figure out this mystery. Uranus is an especially interesting target for X-ray observations because of the unusual orientations of its spin axis and its magnetic field. While the rotational and magnetic field axes on other planets in the solar system are almost perpendicular to the plane of their orbit, the rotational axis of Uranus is nearly parallel to its path around the Sun. Furthermore, while Uranus is tilted on its side, its magnetic field is tilted by a different amount and is offset from the planet's centre. All this may cause its auroras to be unusually complex and variable. This is SpaceTime. Still to come, searching for signatures of life on other worlds. All that and more coming up on SpaceTime. Astronomers already know that any search for life beyond Earth involves a search for water, because where there's liquid water, there could be life. But water isn't the only signature for life. On Earth, gases like oxygen, ozone, methane, nitrous oxide and chloromethane are also important biomarkers found in the atmosphere, and when present on other worlds, they could also be indicators of life. And of course, these are just the ones for life as we know it, that based on carbon. Silicon-based life, if it exists, would have its own set of biomarkers. In fact, there's a whole kaleidoscope of chemical signatures which could indicate signs of life. Of course, many, like methane, could also be geological rather than biological in origin. So nothing's for certain. Still, any search for life on planets and other star systems would also include a search for chemical signatures in the atmospheres of those exoplanets. And that's one of the stories in this month's edition of Australian Sky and Telescope magazine. With the details, we're joined by the magazine's editor, Jonathan Nally.
Scientists are looking ahead to the day when they'll be able to do detailed studies of exoplanets from afar, looking for signs of life. Because the problem at the moment, of course, is that exoplanets, these planets circling other stars, are just so far away. There are only, I think, 3 or 4 that we've, maybe 5 or 6 that they've actually seen as little dots of light by blocking out the light of their parent star. But essentially there are effectively no images of these planets, and there won't be for a very, very long time. But they can pick up some chemical information from these exoplanets and study what kind of gases are in the atmosphere, work out some temperatures, that kind of thing. And as time goes on and technology gets better, they're going to be able to do more and more and more of this and be able to find traces of lots and lots of different chemicals. And the ones they're particularly interested in, of course, are what are called biosignatures. And these are the sort of chemical fingerprints of life form.
Like methane and things like that.
Yeah, methane, even ozone and oxygen, because oxygen's a very reactive chemical, and unless something replenishes oxygen in an atmosphere, oxygen will eventually sort of disappear because it'll get locked up in all sorts of other chemicals because it likes to join up with other things. So you need to have something replenishing an oxygen atmosphere, otherwise it goes away. Methane is the same sort of thing. It breaks down very, very easily. So if you spot something that's got lots of methane, then you need to have some sort of explanation for how it got there. It could be life, or it could be all sorts of other activity like volcanoes and things. So the scientists might be able to detect the presence of lots and lots of chemicals in these planets' atmospheres in the not too distant future. But the problem is how they're going to recognise what these chemicals are and whether they might be real biosignatures or false alarms. So they've built up huge catalogues of thousands and thousands of different sort of gaseous chemicals that we have here on Earth, ones given off by life and all sorts of other ones. They call them volatile gases. And they're building up like a catalogue or a library of all these not biosignatures, but potential, false alarms for biosignatures, sifting out the ones that might be real and the ones that might not be. So that eventually, when telescopes and things get better and our technology gets better, and they do start spotting strange chemicals in these exoplanets' atmospheres, they'll be able to say, could be a biosignature, or no, that's definitely not. And then, give us more information about what could be going on these planets. You mentioned methane. Well, that's a really interesting one because there have been hints that there is ongoing release of methane on Mars.
They've measured it from Earth and even aboard the Mars Curiosity rover. They just haven't found the flatulent cows yet.
Flatulent Martian cows. The difficulty is that the detections they get are tantalising, but they, as you say, they haven't determined where it's coming from yet. And I think I'm correct in saying that they've made detections at the surface, but up in the atmosphere, in the upper atmosphere, they haven't made detections, and they want to know why. Where is this methane coming from on Mars? Because, as I said, methane is the kind of thing that has to be replenished. It just doesn't hang around. It goes very, very quickly. So something's got to be producing it, and there doesn't seem to be any active volcanism on Mars. Perhaps there's stuff going on underground, but there's nothing on the surface that they can spot it, as far as I know. So what is it? And there have been indications of seasonal fluctuations with these methane detections as well. So
it seems to be happening,
thawing out and coming to life during the summertime,
exactly,
and hibernating during the winter. So who knows? And the other interesting detection too, no one's 100% on this yet, but the chemical phosphine on Venus. There were indications that there is this gas called phosphine on Venus, but that's not entirely settled now because of other observations and other ideas. But that's a strange chemical as well. And where is that coming from? What's producing that?
They think they may have solved that one, that it's actually sulfuric acid in the cloud base, and they've just misread the spectroscopy.
Just misread the data. Yeah, exactly. Well, this proves the exact point that it is hard to analyse atmospheres. So if it's hard to analyse the atmosphere of Venus, which is right next door in terms of space, then how much harder is it to analyse the atmosphere of something that's tens or hundreds of light years away, and you're only getting a tiny, tiny amount of data? So they've got a long way to go on that, but it's very interesting stuff nonetheless.
That's Jonathan Nally, the editor of Australian Sky and Telescope magazine. And don't forget, if you're having trouble getting your copy of Australian Sky and Telescope magazine from your usual retailer because of the current lockdown and travel restrictions, you can always get a print or digital subscription and have the magazine delivered directly to your letterbox or inbox. Subscribing's easy. Just go to skyandtelescope.com.au. That's skyandtelescope.com.au, and you'll never be left in the dark again. And this is SpaceTime. Still to come. A new telecommunications satellite for SiriusXM placed into orbit in a spectacular nighttime launch, and later in the science report, Arctic sea ice thinning faster than previously expected. All that and more still to come on SpaceTime. SpaceX has successfully placed a new telecommunications satellite into orbit for SiriusXM in a spectacular nighttime launch. The SXM-8 digital radio satellite was flown aboard a Falcon 9 rocket from Space Launch Complex 40 at the Cape Canaveral Space Force Station in Florida. Following main engine cutoff, or MECO, and stage separation, the Falcon 9 booster successfully returned to Earth, landing on the drone ship Just Read the Instructions, which had been pre-positioned downrange in the North Atlantic Ocean. The landing marked the 87th successful recovery of a Falcon 9 booster. The 8-metre-long, 7,000-kilogram S-band spacecraft was deployed from the Falcon 9 upper stage over Africa 32 minutes after launch. The flight follows last December's launch of the $225 million SXM-7 satellite, which malfunctioned during its orbital raising maneuvers following its deployment. The mission was SpaceX's 18th launch so far this year, and the 8th in the past 44 days. And it's not over yet. 2 more SpaceX flights are slated for this month, including a new generation GPS-3 satellite for the US Space Force, which will become the first military payload to fly on a reused rocket. This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with a science report. A new study warns that Arctic sea ice is thinning faster than previously expected. The findings by scientists at the University College London show coastal regions of the Arctic may be thinning up to twice as fast as previously thought. The thing is, sea ice thickness is inferred by measuring the height of the ice above the water, and this measurement's distorted by the snow weighing down the ice flow. Scientists have adjusted for this by using a map of snow depth in the Arctic that is now decades out of date and doesn't account for climate change. The new study, reported in the journal The Cryosphere, swapped the old map with new computer models designed to estimate snow depth as it varies from year to year. And the new study concluded that sea ice in key coastal regions is now thinning at a rate between 70 and 100% faster than previously thought. A new study claims that 1 in 3 people taking a common arthritis drug failed to produce an effective immune response to the Pfizer COVID-19 vaccine. A report in the Annals of Rheumatic Diseases found only 62% of patients taking the drug methotrexate responded as expected, compared to more than 90% of healthy participants and arthritis patients on other immune drugs. The study recommends more research to confirm the findings and to look into the best vaccine strategies for people taking this medication, like extra vaccine doses, changing the dose of the drug, or perhaps even temporarily stopping the drug treatment. The World Health Organization estimates more than 8 million people have now been killed by the COVID-19 coronavirus, with over 3.8 million confirmed fatalities and more than 176 million people infected since the deadly disease first spread from Wuhan, China. A new study suggests that lowering cholesterol could control the release of a protein from prostate cancer cells, preventing the spread of the deadly disease. Men with prostate cancer that spreads beyond the prostate to other parts of the body tend to have a very poor prognosis, while those whose cancer remains within the prostate are highly curable. The problem is about 4% of prostate cancer cases are detected at an advanced metastatic stage, and less than 40% of those men with stage 4 prostate cancer survive longer than 5 years. A report in the Journal of Clinical and Transitional Medicine claims new research by the Berghofer Medical Research Institute and the University of Queensland has revealed how lowering cholesterol could control the release of HNRNPK protein from prostate cancer cells, which could potentially prevent or at least help stop the spread of prostate cancer. A new study claims that lockdown policies implemented globally in response to the COVID-19 pandemic have had a rather interesting side effect, cutting urban crime rates by 37%. The findings, reported in the journal Nature Human Behavior, are based on studies in 27 cities across 23 countries. Scientists analysed daily cases of crime across America, Europe, the Middle East and Asia to assess the impact of lockdowns on 6 types of crimes, including assault, theft, burglary, robbery, vehicle theft and homicide in each city by comparing them to pre-COVID-19 lockdown crime levels. The authors found the average reduction was smallest for homicide, about 14%, and the largest was for robbery at 46% and theft 47%. Reductions for burglary were 28%, vehicle theft 37%, and assault 35%. The authors also found that the stricter the lockdowns, the bigger the drop in crime. Okay, to once again quote the immortal Dr. Sheldon Cooper, there is absolutely no scientific evidence to support clairvoyance of any kind, which means that fortune-telling is a fraud, the profession is a swindle, and its livelihood is dependent on the gullibility of stupid people. Now, with all that in mind, a psychic has now admitted publicly that Google and social media such as Facebook are among any psychic's best friends as they prepare to give you a psychic reading. Tim Mendham from Australian Skeptics has the details.
They Google you, they Facebook you, they do all sorts of things. There's a story that this came out of in the News Limited website with a suggestion that things you've got to be careful of when visiting a psychic. But this is written by a psychic, so it's interesting that one psychic dobbing in other psychics in a way. If you phone up for an appointment and you give your real name, or especially if you are recommended by an existing client of a psychic is quite possibly, certainly has the opportunity to do some internet research on you and find out your personal preferences and things that have happened in your life, etc., right? If you're going to make an appointment with a psychic, give a different name for a start, and then they'll have trouble doing that. But I was involved on a peripheral level with a case recently of a woman who was very upset and convinced that a psychic knew all about her and knew all this intimate information that she couldn't possibly have known otherwise. And this information was so-and-so and so-and-so and so-and-so. And I went onto their Facebook page and found it in about a minute.
All the details the psychic was claiming to
all the details that the psychic had.
It was all there on the web.
It was all there on their own Facebook page. You didn't even have to go further than that. And I pointed this out. They said, how did they know, he had an interest in bikes and he died in this particular way? And I said, look, all these bikies turned up at the man's funeral, right? You think you'd have an interest in bikes. A whole range of things like that. They were so easily found. People who were talking about it and concerned had not even bothered, but the psychic would. And I would sort of suggest that if you go see a psychic and you don't want to be Googled about it, give a different name.
I would actually suggest you don't waste your money on a psychic.
If you're going for fun, it's not a big issue. You're probably paying twice the amount of money you would to go see a movie. And, and you could easily say, don't go see a Harry Potter movie because it's full of fantasy. Yeah, it's supposed to be. So see the psychics in the same way as a bit of fun, but don't take their prognostications seriously, and certainly don't trust them to say, I saw this in the spirits, when they could easily have found it on Google. Or the big issue is when one customer recommends the psychic to another person who then phones up, and the psychic often pumps the first customer for information on their friend. And that happens quite a lot. Oh, I got so-and-so. Tell them about them. What's their problem? Et cetera, et cetera, et cetera. And the friend might actually give all the information the psychic needs.
Or you could just look at them with your wand and go, Wingardium Leviosa.
You could very much do that, actually, and I think it'd be just as effective.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.